Today we're going to look at positive, negative and zero indices. Now we should already know and be familiar with the fact that if we have something like a to the power of m, then a is known as the base number and m is the index or the power. And the following rules that we're going to look at only apply whenever the base number is the same. So if they're all 3s, they're all 4s, they're all x, then we can apply these rules, but if they're different, then we can't. So for multiplying, we've got, if we get a to the m multiplied by a to the n, that is a to the m plus n. So when the bases are the same and we're multiplying, we add the powers together. If we think of 3 cubed multiplied by 3 to the 4, that's going to give us 3 to the power of 3 plus 4, which is 3 to the power of 7. So we've just added the indices there to get that. For dividing, if we've a to the m divided by a to the n, that's going to be a to the m minus n, so we take those away. So if we have 8 to the power of 11 divided by 8 to the power of 3, that's going to be 8 to the power of 11, take 3, which is 8 to the power of 8. If we have something in brackets, so if we had a to the m raised to the power of n, what we do in this case is we multiply the powers. So that's a to the power of m times n. Now this is an extension of the multiplying rule. If we had 8 to the power of 3, so 8 cubed to the power of 4, what anything to the power of 4 means is that it's times by itself 4 times, so it would be 8 cubed times 8 cubed times 8 cubed times 8 cubed, and using the rules before, that's going to give us 8 to the power of 12. But we also know that if we multiply 3 and 4 together, that's going to give us 12, so that's a much quicker way to do that. Another rule is that anything to the power of 0 is equal to 1. So 5 to the power of 0, 7 to the power of 0, pi to the power of 0 will all equal 1. And for negative indices, so if we have a to the power of minus m, that's going to equal 1 over a to the power of m. So we take the reciprocal and then we make the power positive. So reciprocal is 1 over what you have, and we change it from a negative to a positive. So if we have 3 to the power of minus 2, that's going to equal 1 over 3 squared. Okay, so if we move on to the examples then within the notes, the first example, example A, is a to the power of 5 multiplied by a to the power of 6 cubed. As with anything, we do our brackets first of all. So we've got to a to the power of 5 times a to the power of 6. That's the first row, so we're going to add the indices, and we get a to the power of 11 cubed. And then the next rule, or the bracket rule, means we multiply, so that's going to be a to the power of 33. The next example is c to the power of 5 divided by c to the power of 8. And when we're dividing in the same base, we take away the powers. So that's going to be c to the power of 5, take away 8, which is c to the power of negative 3. Now if we want, we could go on and use the negative power rule to write that as 1 over c cubed. But either would be in a simple way. Example C is g to the 5 times g divided by g to the minus 2. So we have to do the first, we have to do the numerator first of all. And what we'll notice is the g on the right hand side doesn't have a power, but it does. It has a secret power, or not as a secret, but it's a power of 1. We just don't really write it normally. But whenever we're multiplying here, we'll need to add in a power of 1. We'll do the top first of all, and we'll add the powers together, so it's g to the power of 6 over g to the power of minus 2. Now this over means divide, a fraction is the top divided by the bottom, so that's going to be g to the 6 divided by g to the minus 2, which means we're going to subtract the indices, so it's g to the 6 take away minus 2, and the two minuses make a positive, So that's g to the power of 8, because it's 6 plus 2. Example D, we have 4y cubed z multiplied by 3yz squared. Now what we can see is we've got two numbers that are being multiplied together. So we can simply do those first of all. So if we separate it up, we would have 4 times 3, which is 12. We could look at the y's next, and we've got y cubed multiplied by y. Y, remember, similar to the example C, is y to the power of 1. When we're multiplying, we add them, so that's y to the power of 4. And then we've got z multiplied by z squared. Again, z is really z to the power of 1. And that's going to give z cubed. 12 y to the 4 z cubed are all being multiplied together, so they combine to give 12 y to the 4 z cubed. And example E, 2a to the power of 8 all squared multiplied by 3a to the minus 8. Well, if we look at the 2a to the power of 8 squared, what we need to do is we need to square everything inside the bracket. We need to apply the squaring to the 2 and the a. So I could write out the 2a to the power of 8 as 2 to the power of 1, a to the power of 8 squared. And that's going to give me 2 to the power of 2, a to the power of 8. And because it's easy to work out, 2 squared is 4, so that's 4a to the 8. So what we have is 4a to the 8 multiplied by 3a to the minus 8. We can do the numbers first of all, so 4 times 3 is 12. Sorry, I was rushing there. The a to the power of 8 squared, forgot to do that. I think I was so focused on doing the 2 that I forgot about the 8, so that needs to go to 16. And this is a 16, so this is 4a to the 16 times by 3, so now we're back on track. We've got the 4 times 3 is 12, and then a to the 16 times by a to the minus 8. We're going to add the powers together, so 16 add minus 8 is 16 take 8, so it's 8, so it's 12a to the power of 8. The next set of examples were to write in index form. So we had a half, and we wanted to write that in form of an index where it was a to the power of m. So to do that, we need to use our negative rule. Now, first of all, what we can do is we can write a half as 1 over 2 to the power of 1. Using this bottom rule, we've got it in this form here on the right hand side, and we want to express it in the left hand. So we've got the 2 to the power of 1, which means it's going to be the base is 2, and it's going to go from a 1 to a minus 1. So that equals 2 to the power of minus 1. Example B is 3 over d squared. Now, what I'm going to do for this is the same as 3 multiplied by 1 over d squared. And the reason I'm going to write it as 1 over d squared is that we can use our negative rule again. Now, if we have a whole number multiplied by a fraction, that's just the same as multiplying the whole number by the numerator, because it's really 3 over 1. And then we've got the 3 times the 1 is 3, 1 times d squared is d squared, so we can express that as just 3. Now the 1 over d squared, our a value is going to be d, so the base is d, the power is 2, so whenever we write it in this index form, it's going to be to the power of minus 2. So it's 3d to the minus 2. In example C, we've got 1 over 2m to the 5, and I'm going to split that up into 2 fractions, similar to the example above, only this time because the 2 is on the denominator, I'm going to write it as a half times 1 over m to the 5. Now multiplying fractions together, we've got the numerators, 1 times 1 is 1, and 2 times m to the 5 is 2m to the 5, so this is correct. The half is going to stay the same, but the 1 over m to the 5, we can again use this negative rule. The base is m and the power is 5. So whenever we write it, we can express it as m to the power of -5. And we can simplify that to a half m to the -5.